Okay, boss. So we're dealing with indices or indexes. Okay. So we also use indexes to improve the performance of the query bus. So you can build indexes on DSO or you can build indexes on InfoCube also. Yeah. When you look at InfoCube, you would have a primary index and secondary index bus. Primary index is by default maintained by the system. You cannot drop or you cannot create. Okay. And whatever you are manipulating, it is only a secondary index bus. Okay. And as part of secondary index, you'll have two types. One is bitmap index and one is B-tree index bus. As part of secondary index, you have two types. When you just say create index, okay, and that will be secondary index, and that could be bitmap or B-tree depending on the scenario, depending on the cardinality of the data. Now, if the cardinality is less, and if the values in the dimension table, for each dimension table, it creates one secondary index bus. Suppose if I have a cube with 7 dimensions, it does create index 1 for dimension 1, 2, 3, at a 7 index is created. Okay. And for each index, what is the type of index could be bitmap or B-tree bus. When the cardinality of the dimension is less, then it would create bitmap. If the cardinality is more, and if the values are more, it creates B-tree index bus. If you look at the bitmap index, it's like it does formulate index based on the bits 1 and 0 combination like this. If you say B-tree, it's like a binary tree bus. A parent with two children, right child and left child, and right child is always greater than the parent, and left child is less than the parent. So once you compare the parent, and if you're trying to search for something greater than this, you go to the right chain. Yeah. So for every comparison, you're reducing half of the probability, nearing to the half of the probability bus. So when the cardinality values ఎక్కువ ఉన్నప్పుడు బైనరీ ట్రీలో సర్చింగ్ ఫాస్ట్ అవుతుంది, అండ్ బిట్ మ్యాప్ తక్కువ ఉన్నప్పుడు బిట్ మ్యాప్ ఫాస్ట్ ఉంటుంది. సో కార్డినాలిటీ అంటామంటే when the number of records in the dimension table is really less. Whatever వాళ్ళ స్టాండర్డ్ ఏంటంటే లెస్ అంటే ఇట్ షుడ్ బి విత్ ఇన్ ద 20% of your fact table. Number of records in the dimension should be less than 20% of the fact table. Then they consider the cardinal to be less. Then they go with what? Bitmap. If it is more, then they go with what? B-tree bus. Okay. And the point here is, when you create secondary index on a cube, it improves your query performance, but it does disturb your loading performance. So to handle both, what they do is, whenever they are loading into cube, they will drop the indexes or nothing but delete the indexes. They load the data, then recreate the index. That's how they handle it. Okay. Now we'll have to know how do we create index on this. Yeah. Compare it to loading data into the cube when there is indexes maintained. That would be less. But if you're loading some 2 records, 3 records, doesn't make sense. But if you're loading millions of data, it always makes sense to drop, load, and recreate it again. Always. And how do we basically? Let's say I have this cube. What on the? So I have a cube here. I have a cube here with all these dimensions here. Okay. Now let's say I said, when you say create index, you're creating second index. And does it create index for each dimension? Data packet, time and unit, I've got 1, 2 and 3. Yeah. Now for each dimension it does create one second index, but how do you control whether the index for this dimension is supposed to be bitmap or btribus? When you right click on this dimension, then you have what? Properties. When you right click on the dimension properties, you have a checkbox here. What is? High cardinality. When you indicate that the number of records in this dimension table is going to be huge with this checkbox high cardinality, it does create B-tree index. If you don't select this, it creates bitmap. So for dimension 1, I said high cardinality, so it is going to create B-tree for this. Just activate this. Now I would like to create indexes on this cube. Right click on this cube and say what? Manage. The tab, what is tab here? Performance. There are two things here. One is create DB index, batch and background. Create DB index, delete DB index. Now I would like to say, check ante indexes already undi. So I would like to delete DB index. So start. But in the real time, we don't do like this for every cube. We'll be scheduling it in the process chain, but we can, this is our deleting. I will check index, it says what? Red, the index are deleted. Now we want to create index back. There's a job running in, you can check the job status here. It's finished here. If I check now it says green, the indexes have been maintained. Now if you want to literally see those indexes, now what is my queue? YCYMP 01, right? Now go to the T code SC14. What is F/BA/F cube fact table, and click on this button. What is the button? Storage parameters. You will see these indexes. Look at this. These are the secondary indexes. 40, 50, 60. And if I drop this out, we cannot see data exactly how it is in PowerPoint. We cannot really see that data. What's happening to this? No more indexes. Like this, you can drop and create indexes. Now what I'm saying high cardinality is greater than 20%, all this, right? That is all understood. When you see a dimension like with, say, I have a dimension assigned with sales order number. I am loading 1 lakh sales orders to my cube. What will be size of the dimension table? 1 lakh, because for each order it will generate one dimension. Based on that you do, but if you still want some program to calculate that and tell you it is 20, you can always check number of records and do that also. But while designing the cube itself, they'll identify that, saying this dimension is going to be huge, so they'll select what? High cardinality. And we can also for a cube we can drop and recreate all cases. And we can also deal with indexing on DSOs also. Even for DSO, I can also create my indexes. See, in older versions, when I wanted to create index on a DSO, what we used to, normally when you do reporting on DSO, from which table does it fetch data from? Active table. So what I used to do is, we used to go to SC11, explicitly open the table, active table, yeah. Let's say I got customer and Calvin. Let's say I would like to have let's say we are running some queries which is doing some where clause on region. అంటే నువ్వు బిగ్స్ క్వరీ చేసిన ఫిల్టర్లో రీజన్ ఈక్వల్ టు సౌత్ అంటే వేర్ క్లాస్ సౌత్ మీద రీజన్ మీద ఉంది. సో జనరల్లీ వెన్ యూ హ్యావ్ ఫిల్టరింగ్ ఆన్ నాన్ కీ కాలం ద పర్ఫార్మెన్స్ ఇస్ స్లో. సో ఐ వుడ్ లైక్ టు హ్యావ్ అన్ ఇండెక్స్ ఆన్ దిస్ రీజన్. దెన్ వాట్ ఐ డూ, క్లిక్ ఆన్ దిస్ బటన్, వాట్ ఇస్ ఇండెక్స్ and say create index. And then I should say unique or non-unique, and then select the field. What is the field here? Region. And then save, and then now index exists in my database. Now like this, we used to create index manually like this. Yeah? But now I've deleted it now. But now what SAP has done is, at the time of creating DSO itself, we have folder. What is here? Indexes here. Right click, again say what? Create new index. 0 and 0, non-unique is okay. So create. So then 0 and 0 is created. Index here. Now what columns you want into this? Region. Something in the area. Elevate, right? Activate. So it has created these indexes. ఇక్కడ నుంచి చేసినా అదే అక్కడ నుంచి చేసినారు అంటే అక్కడ ఫస్ట్ అక్కడ లేకుండింది. In 3.5 we never had that folder as indexes, so we used to manually get into SC11 and create our indexes. But now SAP has given flexibility of indexes in the DSO management maintenance screen, where you can go creating indexes there itself. Okay, and indexes for a DSO, there's no option of dropping and recreating this. But for a cube, you have option of dropping and recreating it. For DSO, once it is created. If you drop, that's it. We cannot really schedule that in the background, not possible. Okay, boss? Yeah. And this is very, 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 very important. Right? You don't really see those nodes like that, but this is really effective, boss. Because I had a scenario, and generally in the interviews, they were asking me, tell me some complex scenario. I was saying, I'll give you some interesting scenario if required. చెప్పంటే అంటే నేను నిజంగా ఇది ఫీల్ చేసిన అన్నట్టు ఏంటంటే, there was one big, you know about RRI, jumping from one report to another report. Good. User has raised me a ticket saying, boss, I'm running this report. From this report, I'm jumping to another report. When it's jumping from report 1 to and the main report is built on a cube, and the jump report, the second report was built on a DSO bus. One point if when I'm jumping from main report to sub report, it is running for 2 minutes. Can you please improve the performance of this query and ticket? 2 minutes kada danike pedda ante ఆ 2 minutes నేను 80 times జంప్ చేస్తాను రోజు. 80 into 2 minutes చేసుకుంటారు. అర్థమైంది క్వశ్చన్? సో యూ వాంట్ మీ టు ఇంప్రూవ్ ద పర్ఫార్మెన్స్ ఆఫ్ దిస్ క్వెరీ బస్. సరే, నేనేం చేసిన అంటే, వెన్ యూ గో టు RSRT ఏదో ఒకటి, వెన్ యూ సెడ్ execute plus debug, we have an option called display SQL query bus. When you but when you see this query, if there are any filters, you can see the where clause on it. For example, దీనిలో డేటా ఏం లేదనుకుంటా. ఓకే, నాకు డేటా కాదు ఇంపార్టెంట్, జస్ట్ అట్లా ఫిల్టర్ పెట్టినా అనుకున్నా. చూడు, వేర్ మంత్ 8 ఏదో ఉంది. We can find out. Join on 8 is one SID. With this, you can find out what is this SID is exactly. Then we can find in the S4.SID. S4.SID we can understand month, and what is the S1.SID? S1 is what? Customer number. So customer number SID. This is customer number SID. This is region SID. Our mode single where class guchindi. Yeah. So then what we thought, okay, if you can build index on this DSO with these three columns like month, customer and region, that should improve my performance ani anukunna. And as soon as I go to this DSO change, I could see that వెళ్తే వాడు కూడా ఇండెక్స్ చేసి పెట్టాడు ఆల్రెడీ. I wanted to improve the performance by creating index. So when I go to the ODs, I already saw there is an index built already for region and month and customer. ఇంకేం చేయాలి రన్ చూస్తుంటే then what I just read it somewhere that the index columns in this index must be in the same sequence as of where class. Where class column sequence ఎట్లా అదే సీక్వెన్స్లో కూర్చుంటేనే ఆ ఇండెక్స్ని పట్టుకుంటుంది, లేదు పట్టుకోదాన్ని. So what I did is I just adjusted the six in the where class, 6 columns. I just adjusted those 6 columns in the same sequence as if in the where class bus. It was running for 1 second. Query was jumping in 1 second bus. అది అంత ఎఫెక్టివ్గా ఉంటుంది అంటే ఆల్మోస్ట్ 200 times అన్నట్టు ఆల్మోస్ట్. ఓకే, సో ఇండెక్సింగ్ బాగా ఎఫెక్టివ్గా ఉంటుంది అంటే వాడే విధంగా వాడాలి. బట్ అట్ సేమ్ టైమ్ ఇండెక్సింగ్ విల్ డిగ్రేడ్ యువర్ డేటాబేస్ స్పేస్, డాక్యుమెంట్స్ మోర్ స్పేస్ అగైన్. అందుకే హ్యానా వచ్చినాక ఇండెక్స్లు ఏమొద్దు నేను చూసుకుంటాను. సో నో నీడ్ ఆఫ్ ఎనీ ఇండెక్స్, ఐ విల్ టేక్ కేర్ బికాస్ దే హ్యావ్ అ న్యూ మెకానిజం ఆఫ్ స్టోరింగ్ టేబుల్. నా table each column itself is like index, so you don't have to create any index anymore.